we wrap up this astronomy unit in looking at ultimately what the best evidence says that how our universe came to be. And it's going to go back to the proverbial Big Bang ultimately, but the Big Bang was neither big because we think it was very small, nor was it loud because actually to make sounds we need to have atoms and that sort of thing, and there weren't anything for the energy to propagate through. But it's thought that our universe is 13.5 billion years old, and this number might be in flux a little bit, but it's out there. I think it's only getting older than younger, and it's thought that, actually I mentioned Big Bang, that all the matter that makes up our universe, the matter and the energy that makes up our universe, was just in a small place called singularity. Very dense place. And I'm really boiling it down to just a kind of few key points. So I feel a little guilty because there's so much more to this. But basically, at the time singularity kind of unloaded, it was all energy. And that energy over time, a large amount of that energy converted actually to matter. According to Einstein's E is equal to mc squared. So the energy rushed from that one location we call singularity, and as it rushed, it actually took with it or created with its kind of expanding into nothingness, space and time of this universe. As it expanded, it cooled, and like I said, a large amount of energy was converted into a small amount of matter, according to E is equal to mc squared, where E is energy and m is mass and c is the speed of light. So we have quite a lot of energy being converted into a little bit of matter. But that actually was all the matter and all the energy that the universe currently has. So I just think that is so cool. So the universe expanded. Now when we say the universe expanded, we're talking about the fabric of space and time, the space and time reference that we call our universe expanded. And it continues to expand and cool today. So we can see its expansion actually by using redshift. And I think, or the Doppler effect and redshift. I think we talked about the Doppler effect before when we said if something is moving away from us, okay, this is an object moving away from us, the wavelength that we see is longer lengthened, longer wavelength if it's moving away from us, if this is us. So color-wise, if we look at the color red, okay, the color red is the longest wavelength. Actually, though, I will say that we've got, must have been on the previous slide. Oh, no, it's coming up. We have a spacecraft out there, or a telescope that is just looking for that Doppler shift. So just a few more things about the Big Bang. If this is actually showing you singularity right there, singularity. And what this figure is doing is kind of showing you time, and it's also showing you kind of expansion and kind of the creation of things. So, yeah, there was this thing called inflation, and inflation is different than the expansion of the fabric of space and time. Inflation actually violates rules of physics, basically, and it happened very, very soon after the Big Bang. And I guess another thing I'll mention is that it took cooling and expanding some 38,000 years, 380,000 years after the initial Big Bang in order for the matter to cool down long enough to basically electrons go ahead and become associated with nuclei. Before that, electrons were buzzing around and we actually could not see anything. Photons could not move across space because they'd run into electrons. So that's when we say the universe became transparent. The first stars were formed some 400 million years after the Big Bang. Okay, and so we say our sun is about 4.6 billion years old. Our sun is actually a second, third, fourth generation star. So currently the universe is still expanding, although this expansion has been in the news. This is fall 2017, and I think it was in the news just this fall or this summer, that the expansion isn't what we necessarily thought it necessarily was. But we actually see the expansion accelerating, which is kind of scary. And its acceleration is most likely due to not dark matter, but the presence of something else that's dark, generally called dark energy. And I mentioned that there was a spacecraft or a telescope out there looking at kind of the remnant energies from very far away, distant reaches of our universe, and understanding some of the early on phenomenon associated with the Big Bang.